So now for page 2, the first problem, number 3, gives us a population function and asks a few questions about it. Part A is not a calculus question. What is the population 8 years later? Okay, so when t equals 9, probably this 8 should have been a 9, but if anybody appeared confused about that, I gave you all the points. All right, so I should also say this page is from the second version of the exam. So this is the page that the 12 o'clock and 1 o'clock sections got. Very slight differences on problem number 3 here. So the population when t equals 9, we're just going to plug in 9. It's set up to make the arithmetic easy. 20 times 2 to the 9 thirds. Well, 9 thirds is 3. So 2 cubed is 8 times 20, 160. Like I said, no calculus. Now part B is calculus because we're asked for the rate of change. So we need the derivative. P primed of t equals the constant 20 times the exponential function. Because the base is not e, we get the function times the natural log of the base, ln2, and the chain rule times the derivative of the inside. That's the derivative, and then again we're asked to evaluate it when t equals 9, so we'll plug in 9. Let's pull these constants up in front. It looks like I have 20 thirds ln2. And then we're going to plug in our 9, which gets another 2 cubed, which is 8, just like it was up here. And times that 120, so 160 thirds ln2. Which would be members of the population per year. People, frogs, whatever the population is, we're not told. Only that it's the population of a region. All right, number 4, find an equation of the tangent line. So to find the equation of a line, there are a couple of things we need. We need the slope. Let me write the point first because it's obvious. The point is handed to us, and so really what we need is the slope. And I suppose we could solve this for y. It's a quadratic equation, but that's not what we're going to do. We're going to differentiate implicitly. So xy is a product. We're going to use the product rule. So y is a function of x. So I get x times y's derivative plus x's derivative times y. The derivative of 18 is 0. The derivative of 3x is 3. Y is a function of x. And then we get a composition, 2y squared, so 4y, y prime. So factor the y primes out, I got an x here. We're going to subtract this term to the other side, pull off the y prime. Makes minus 4y. You can see how that works. And then the non-derivative terms, we have 3, and then this y guy is going to come over, subtract. So y prime, running out of space here, is 3 minus y divided by x minus 4y. Then we're going to evaluate at the point 1, 3. So, yeah, kind of a quirk here. I didn't exactly plan this, but that's okay. The 8 o'clock class got a non-zero slope. If I remember right, I want to say it was negative 3/2, following exactly the same process. So coincidentally, it turns out the slope is 0. So that means the equation of a line is just y equals 3. Obviously, the line passes through the point 1, 3, and it has slope 0. So y equals 3. The 8 o'clock class, like I said, you didn't get 0, so you would have to use the slope-intercept form, which we know and we've used many times. So the 12 and 1 o'clock classes lucked out just a tiny little bit by getting a slope of 0. All right, and then maybe problem 5, the next problem, it was a little more difficult for them. I mean, not really. The 8 o'clock class, we had I'm going to clean this up just a little bit. Hopefully you've got down what you need there. If not, you can pause it, I guess. I'm going to get this out of the way. There we go. So 12 o'clock and 1 o'clock, we have a triangle. 8 o'clock had a rectangle. Everything else about this problem is the same. The numbers are different, but it's the same as far as the math we have to do. So let's read this. The horizontal leg of a right triangle. So step 1, step 2, draw a picture. The horizontal leg, let's call it x, is increasing. Well, looky there, dx dt. At the rate of 3. It's increasing, so plus 3. The vertical leg, column y, is decreasing in such a way that the area remains constant. So it appears that area is an important thing. And notice it's 50. So area is constant. So how can I relate x and y in equation? This would be, so step 1 is right here, reading the problem. Step 2 is identifying the variables. We have one more to do, and that is which derivative are we looking for, and it's dy dt. So we know the area, which is 50, of a triangle is 1/2 the base times the height, x and y for us. So I would multiply by 2. Why not? You don't have to, but some people made a mistake with that 1/2. So 100 equals xy. And now we'll differentiate implicitly. Over here we have a product. In fact, the same product we had up here on number 4. So x, I like to write dy's because we're differentiating with respect to time on these problems, plus y dx dt equals the derivative of 100. That's a constant. The derivative is 0. So we need to solve for that thing. It's easy to do. Just subtract this term over. So dy dt equals minus, and we're going to get a y dx dt, and then we have to divide by this x. So there it is, and now plug the information in. When the vertical leg is 4, so 4 goes on top, dx dt we know is 3, and we need to figure out what x is. So if you go back up here to the relationship, actually let's take this line right underneath it, 100 equals xy, and we know the y value is 4, and therefore x is 25. Plug it in, and we get negative. Thank goodness we get a negative answer. I mean, we were told that side has to decrease, negative 12/25. I didn't ask for the units. They are centimeters per minute. Okay, page 2.